Question 6 says, imagine you could freeze an ultrasound of wavelength 5 millimeters as it travels through tissue. So in terms of reading this question, we should probably note down straight away this is 5 times 10 to the minus 3 meters. So we're picturing a sound wave passing through some tissue, and we've sort of frozen it in time. We're kind of used to this idea because we're used to trying to draw a representation of a longitudinal wave, where we might end up doing something like this to represent the sort of spacing of the particles in a longitudinal wave. So we want to picture that sort of snapshot of the longitudinal wave. We've said already that the wavelength in this case is equal to 5. Well, it doesn't give us that significant figure, does it? 5 times 10 to the minus 3 meters. So how many waves would there be in a length of 1 meter? Well, this is just a case of working out the number. So we've got the total length over the length per wave, which of course is known as the wavelength, length per wave, sorry. So that's just 1 over 5 times 10 to the minus 3. So that's 1 over 5 is 0.2, so 0.2 times 10 to the 3, which gives us 200. So that's the number of waves in 1 meter. So it's just a number, so it doesn't have any units on. State the relationship between the wavelength and the wave number. So the wavelength is equal to 1 meter divided by the wave number, or you could have written it the other way around. So we might write 1 meter is equal to the wavelength multiplied by the wave number. State the quantity that is the reciprocal of the wave frequency. So yep, we have the time period here, don't we? Which we know is 1 over the frequency. When we write that down, show that the wave equation is dimensionally consistent. So our wave equation is V is equal to F lambda. So if we're writing this in units, the unit of velocity is meters per second. The unit of frequency that we'll start off with is hertz, and then we're multiplying that by the unit of distance, which is meters. But as long as we remember that the hertz is equivalent to seconds to the minus 1, then we can see that these two are dimensionally consistent with one another.